Good morning. Today we'll be doing a gel electrophoresis lab, and we'll be doing it to separate different solutions of dye. And from what we could see is that large molecules stay at the top, whereas medium molecules stay in the middle part, and the smaller molecules move towards the positive electrode. Move on to the materials. The materials that we'll be using are three solutions: a one-time sodium buff borate buffer. We'll be using the micropipettes and as well as other electrophoresis equipment as the aggregate gel, the gel electrophoresis power supply, and the power supply leads. Let's move on to the predictions. As it says here, I believe the simulation will be using gel electrophoresis to separate three different dyes. These dyes different size, with yellow being the smallest, blue dye being larger, and purple dye being the largest. If these dyes were equally in negative charge, how far do you predict the dyes would move in the lanes during gel electrophoresis? So from what I believe, since yellow is the smallest, I believe this will move farther down. Blue being the medium size, I believe it will be in the second half, and the purple would remain in the first half. That is my prediction. We'll move on to the protocols. We select the aggregate gel. We place the gel in the aggregate in the gel electrophoresis box. Now we orientate this so it's in the wells are towards the negative side. Okay, we close this. Now we pour the buffer into the gel. Once we do that, we move on to the next step, which is to select the microfuge to open the lid. Select and move each of the solution into the microfuge. Now we balance this. Check balancing. Okay, it's look good. So now we close the lid. Press the pause button to briefly spin it. So once that is over, we open this and we move the solutions back into the racks. And we close that. As you can see, the racks are back. Now we close the lid. Move on to the next step, which is to make a note to show in which solutions pipetted into each lane. So solution 1 goes into lane 1, solution 2 lane 2, and solution 3 to lane 3. We save the note. Now we select a P20 micropipette and we change the volume to a 10 microliter. Okay, we save the volume. We open the P20 tip box and we get a tip. Okay. Now we close the tip box. Now we choose solution 1 and place the micropipette into it. And we draw solution up. First stop. Now close solution 1. Move on to the next step. And we open the gel electrophoresis and we put over it. And now we select the first one and we expel the liquid. So once that is done, we move this into the trash. Check the tip. Move on. We get another solution and we do the same thing for both solution 2 and 3. Once that is done, we check the tip. So once that is done, we put it back into the trash can. We place back the P20. Now we move on to place the cover over the electrophoresis box. Select the red and black cable. Okay. So once that is connected, we turn on the power supply. We select the voltage to 130. Once that is done, we set the timer for 10 minutes. Okay, we started. We just wait until the 10 minutes passes by. So once that is over, we turn off the switch and we unplug the electrode. Carefully remove the cover from the electrophoresis to inspect the gel. Move on to the next step. Okay. Now to the results. Look at the relative position of the dye bands in your gel. Compare your results with your ideal result by making notes and describing any difference observed between the results. Explain why the bands ended up in the relative position. So my actual results are here and my ideal results are here, and we could see that these are the same thing. I got my actual results just as my ideal results. They move on to the positive electrode, both of them. Move towards the positive electrode. So we just type it. They are the same because size does not only play a role into as where they're going to move, but actually the charges play a role onto which part they will move, into the negative electrode or into the more to the positive electrode. And we can see that they move more into the positive electrode here from my negative results. From my actual results and my ideal results. It says, based on size, you may have expected the blue band to migrate farther than the purple dye, and the yellow dye to migrate the farthest. In practice, the larger purple band moved farther than the smaller band due because not only the size of the fragment but also its charge determines how far it migrates into the gel, as I said before. What part of the procedure you think had the greatest impact on the results obtained? The part of, I believe it is the part where we did the power supply and where we introduced the electricity into this to the agarose gel, as this determines where does it move into. I believe that this part of the procedure has the greater impact on the results. Now let's move on into the reflection. Study your agarose gel. Number 1, I believe is 3 based on the number of the bonds. What charge did the dyes in the experiment have? I believe they are all negative because they move towards the positive pole. Number 3, the dyes you separate in simulation are orange, purple, and blue. If these dyes are fragments of the DNA, which color would be the smallest piece of DNA? 3, this would be yellow. Submit. Number 4, if you compare two molecules that were found in blue bands and if what you infer about them have the same size and charge. If you run number 5, if you run a gel like the one picture below, the wells in the middle, and load it positively charged molecule into gel, where would you expect this gel to move? These would move into A because the positive molecule will travel to the negative pole. I feel very confident in doing this lab in real person time. And that was the end of the simulation. Thank you.